Howdy, folks. October 1st, man, crazy, right? So we're in day 4 of lecture on our unit on graphing, and now today we get to talk about velocity versus time graphs. Okay, so we spent kind of all day Tuesday talking about distance versus time. So now we get to start with this one. All right, so here we go. Let's start it up. All right, so we asked the first question here. Where's the location that an object will not be moving? At rest, stopped, stationary. Notice white font there. Okay? So if we want to talk about an object at rest, stopped, stationary, the velocity for those are 0, right? So when we look at this, this should be just along that t-axis there, right? Where velocity is 0. Okay? Now if we're looking at that point, then what we're seeing is our direction is not moving. Our velocity is 0, our acceleration is 0 as well. Okay? So don't forget that becomes an option for us. It's just like in that d versus t where we see a flat line, right? Same concept for us. All right? So now, when we talk positive and negative velocities, this is a big deal for us because positive and negative velocities become a very kind of important position for us to be able to talk through and see. All right. So when we talk positive velocities are in that top half quadrant. Now, it doesn't mean that our change in velocity is still always going to be positive. We can still get slowing down, right? Meaning you're coming up to a stop sign, you're coming up to a stoplight, you're going to slow down. But because if you're moving in the correct direction, away from where we're going to, forward, positive, to the right, so to speak, that's where those positive velocities are going to be. Negative velocities, obviously, going to be below the 0 mark, all right? Again, if you look at that graph, we could still have increases and decreases there, but that's where our negative velocities tend to exist. Please understand, this is not a math class. When we look at negative velocities, what we're going to see is these are going to be spots where it's just going the wrong way. So we could be going fast the wrong way, we could be going slow the wrong way, but that's where those negative velocities are going to exist. Okay? Positive velocities mean forward direction. So in the top part, that's going to be our forward direction, right? Just like when we're seeing d versus t, if we're seeing that upward slope, that means forward for us. Okay? Negative velocities mean backward direction here. For us, anytime we see a graph drawn in that negative velocity region underneath that t-axis, that means we're going to have backward directions there. It's just like seeing that downward slope on the d versus t graph, okay? That downward slope means we're actually traveling backwards, all right? In this graph, above the t-axis is forward, below the axis means we're going backwards, okay? Let's try one out. So we got the curve there. So first and foremost, we're looking for direction. So the hope is that as you look at this direction, we see this is above the t-axis. So what that means for us is this thing should be going forward or positive, all right? Yeah, we could talk about going to the right, but really for us, forward or positive becomes the big deal, okay? Velocity. Now, when we look at this one, we're going to ask the question, is the velocity 0? Is the velocity constant but not 0? Meaning, is it 1, 2, 3, 4, 5, something like that, some actual numeric value? Is it increasing is our third option? Is it decreasing is our fourth option? For us here, what we should see is it's not 0. The reason it's not 0, it's not on the t-axis. Okay? Is it constant but not 0? Absolutely, right? Depending on the curve or the scale of our graph, what we're going to see is this thing is constant, all right? If our velocity is constant, our acceleration then, is it positive? Is it negative? Is it 0? With a velocity that's constant, that means that our velocity is not changing. Our initial and our final should be the same. So if we subtract those two, we should see our acceleration is 0. Now, yes, it is going to be constant, but for us, the big thing is our acceleration is 0. We're not speeding up, we're not slowing down, we're going at the same rate of speed the whole entire time, okay? Check out the next one. Again, in the top part of the graph. Because it's in the top part of the graph, the question becomes, is it moving forward, backward, or no movement? Is it moving positive, negative, or no movement? All right? For us here, this is moving forward, this is moving positive, right? Because it's still in that top part of the region. The velocity, is it 0? No, because it's not on the t-axis. Is it constant? This one is not constant. The reason it's not constant, it's not that flat line, right? Is it increasing or is it decreasing? If we look at just the straight up numbers of these two here, what we're going to see, let me get my pen going here. All right, that versus that. So if we look at where that ends up versus that ends up, our velocity should be increasing, right? So if it's increasing, that means that the velocity numbers are getting bigger. We're covering more distance in a shorter period of time, right? If it's increasing and we're getting bigger velocity numbers, that means we're speeding up. Speeding up means our acceleration is either positive, negative, or 0. In this case, because our velocity is increasing, this should be positive. Now, because it's a straight line, that also is going to mean that it's constant. If we get a curved line, it's going to be variable, all right? For us, we won't see curved lines. We'll see straight lines mostly, okay? Next one. All right, this one now, notice what the location of it. Our direction, is it not moving? No, because it's not on the 0. Is it forward or positive? No, it's in the wrong region for it to be forward or positive. This one has to be backwards or negative, all right? Velocity, is our velocity 0? No, because it's not on the t-axis. Is our velocity constant? Absolutely, this thing is constant for us, right? It's a flat horizontal line that's parallel to the t-axis. It's not getting bigger, it's not getting smaller, it's just staying the same rate. Remember, this is like setting our cruise control on our car to drive at 60 miles an hour. Once we set it at 60, that car should cruise at 60 miles an hour, regardless of hills, valleys, turns, and stuff like that. Okay? If our velocity is constant, our final velocity is the same as our initial velocity. If those two are the same, that means that our net result should be 0, so our acceleration is 0. It's not positive, it's not negative, it's just not changing for us, okay? 0 and constant, same thing for us. All right? How about this one? When we look at this one, right? Now, for us here, the direction, is it positive? No, it's in the wrong region. Is it forward? No, it's in the wrong region, all right? Is it not moving? No, it's not on the t-axis. So this one for us has to be backward and negative, right? You could say it's to the left. I'm not going to worry too much about the left, all right? So if it's going backward or negative, remember, that just means it's going the wrong way. That's all it means, right? We have to go north, but in order to go north, we have to go south first because we missed our exit at 185th, or however you want to describe it, okay? Velocity here. This one's really tough because when we look at our velocity here, what we see is it starts at a large negative value. Over here, what we see, sorry, not the straightest line ever, is it's getting less negative. In math class, this is going to mess us up. Because in math class, when we look at this number at the bottom here, right here, versus this number here, in math class, that number is smaller. But please remember, if we're going backward or negative, it just means we're going the wrong way. We still have a large velocity number here, right? Our speed is still big. Our speed there, let's say it's 40 meters per second, right? At the bottom here, our speed is going to be less than 40 meters per second. Our velocity should be decreasing, right? The number should be getting smaller. Throw out the negative. Just look at it as straight up speed. Our speed in that case should be getting less and less and less and less, right? It should be getting closer to 0 because the 0 mark is right there, okay? So if we're decreasing, what does that mean? It means we're slowing down. So our acceleration at this point is negative. Because our final velocity is less than our initial velocity, when we take final minus initial, according to the formula, that's going to make a negative value because our final is going to be a smaller number than our initial. Okay? All right. Here we go. All right. Direction for this one. Now, I'm not going to write it out. So I'm going to see, can you figure it out first? Okay? So I'm going to give you a minute or two, pause the video, see if you can go through, see if you can answer these questions by yourself first and foremost. Okay? So go ahead, pause it, and we'll see. All right. Hopefully you paused it. If you didn't, I get it. Okay? For us here, direction. Is it not moving? No, because it's not on the t-axis. Is it going forward or positive? No, because it's not in the positive v-axis, right? Or in the positive v region, in the top part of the graph. So that means it's going backwards or negative, all right? Velocity now. The hard part about velocity here is your frame of reference. In this case, our velocity, if we look at it and just say straight up speed, because this thing's already going backwards, the straight up speed of it, the value of the v number for us is going to get larger. What that means is our velocity is increasing. Okay? This thing is going to be going faster. The velocity is going to get bigger. Even though it's going the wrong way, it's still going faster. You missed your exit, so you're going to speed up and try to hit the next exit, make up time. Okay? Acceleration for us here, because this thing is speeding up, because the velocity is increasing, our acceleration here should be positive. Okay? Now, last bit for us. Now, that was all our velocity versus time graphs. Okay? So, check out this one. This one's got some funkiness to it. It's almost like in F1 racing, they measure everything. So what they're able to do is see through F1 racing, like when the acceleration was the greatest. All right, around this curve, you lost time because you missed the apex of the curve. Okay, this curve here is pretty similar to that. But now notice something unique. This is a distance versus time graph. Okay, so when we ask where is the positive velocity the greatest, positive velocity now means that we're increasing speed, right? So what we want to see is where are we increasing speed? For us, increasing speed is going to be part A and part C, all right? So for us, which one has the greatest increase in speed? Well, that is going to be part C. And again, the reason why part C has the greatest increase in velocity is because its slope, its angle, is the highest. All right? Next one. Where's the negative velocity the greatest, right? So now we're talking about losing distance or going backwards in distance, right? So for us, when we look at negative velocity, really that just means we're going the wrong way. Which one has the fastest option for us to go the wrong way? Well, that's going to be part D or part F. Well, in this case, we look at which one has the steepest slope, D or F. Hopefully you're answering this one as part D does, right? Last bit, where's the velocity 0? Velocity 0, remember that means that our object is not moving. It's not increasing its distance, it's not decreasing its distance. It's not going forward, it's not going backwards, it's not going positive, it's not going negative, left, right, all that stuff. For us, this means where's the flat line? So the flat line here, not A, B for sure. C, I suppose we could talk about at the top here, right? Eventually between C and D, we're going to get a little bit or a momentary stop before we change directions, right? But again, that's not a point that's marked for us. So we look at E, we look at F, E for sure. So what we start to see is B and E, okay? Now, what you're going to see tomorrow is you're going to see all of those different graphs that we went through. You're going to see questions where we ask, is it going forward? Is it going backward? Is there no movement? Is it going positive, negative, no movement. Right, left, no movement. Is the velocity increasing, decreasing, or zero? Or constant, not zero? Like that line on the D versus T, like part A, where it's just going upwards. That's a constant, but it's not zero. Okay? Is it increasing? Part C. Is it decreasing? Part D. Okay? Acceleration. Is acceleration zero? Part A. Part B. Part E. Is it positive? Part C. Part Part C mostly. All right. Is it negative? Part D, part F. Okay. Those are the things that we start to look for on our quiz for Friday. I'll make sure that in the email I include the different topics that we're going to address, topics we're going to look at. But otherwise, make sure for Friday you take some time, look over those graphs, organize the graphs, make sure you finish homework, and then make sure you set aside somewhere between probably 10 and about 18 minutes to do the quiz. Okay? Otherwise, if I don't see you, hey, have an absolutely fabulous weekend. I'll look forward to seeing you on Monday. My distance people, I hope we can touch base at some point in time here going forward. Okay? My bee hybriders, we'll see you on Friday for sure. Okay? Take care. Have an absolutely fabulous day. All right.